Hi guys, we are Team Technocrats with mentor Mr. Sri Geeta M and team lead Preeti S. We have chosen natural language processing as our domain. In recent years, the volume of textual data has rapidly increased. To retrieve useful knowledge within a reasonable time period, these information must be summarized. So, we have come up with an approach for abstraction-based text summarization. Abstractive summarization is a type of text summarization which rephrases the original text to generate new phrases that may not be in the original text. It is better than extractive summarization since the summary is an approximate representation of a human generated summary which makes it meaningful. So we have used some of the deep learning models and techniques in order to generate the summary. The models that we have used are autoencoders, LSTM, attention mechanism and beam search. Autoencoders generally consist of both encoders and decoders. Here, bidirectional LSTM with dual attention mechanism is used for encoding and unidirectional LSTM with beam search is used for decoding. So, there are two flow diagrams. Firstly, dual attention approach. The proposed dual attention approach consists of three modules, two bidirectional LSTM encoders and one dual attention decoder. The decoder has a gate network for context selection and employs copying and coverage mechanisms. The outputs of the encoders are two context vectors, one context vector for sentences and one context vector for the relation. The relation may be a triple or tuple relation. A triple relation consists of the subject, predicate and object, while the tuple relation consists of either subject and predicate or predicate and subject. Sometimes the triple relation cannot be extracted. In this case, two tuple relations are utilized. The decoder gate merges both context vectors based on their relative association. Secondly, the context and entity encoder with dual pointer network decoder. The pointer network is a sequence-to-sequence model in which an attention mechanism is modified to learn the conditional probability of an output where the value corresponds to positions in a given input sequence. We modify the pointer network to include dual decoders, an object decoder and a subject decoder. There are two main parts, context and entity encoder, dual pointer network decoder. The context and entity encoder computes the degree of association between words and entities in a given sentence. Here, W1, W2 to Wn are word level embedding for representing the meaning of words and character level CNN embeddings for addressing out of vocabulary problems. The word embedding vectors are used as input for a bidirectional LSTM network to obtain contextual information. C1, C2 to Cn are the output vectors of the bidirectional LSTM networks and S1, S2 to Sn are output vectors of forward LSTM. These outputs are used as input for context to entity attention layer to compute relative degrees of association between words and entities. The context to entity layer output OT is determined through a fully connected neural network using a concatenation of heads as input. In a pointer network, attentions show the position distributions of an encoding layer. Since attention is highlighted at only one position, the pointer network has a structural limitation when one entity forms relation with several entities. The proposed model adopts a dual pointer network decoder to overcome this limitation. So our approach is the combination of these two models. There are many existing models which provides abstraction-based text summarization that involves GRU with attention mechanisms, LSTM approach and so on. But we have proposed a model that combines LSTM with double attention pointer network. This will provide more contextual phrase generation efficiency. Thank you.